For decades, the standard treatment for chronic back pain, especially when linked to intervertebral disc degeneration, has relied heavily on mechanical and invasive solutions: spinal fusion, discectomy, laminectomy, and increasingly, total disc replacement. These procedures can be effective in select cases, especially when nerve compression or structural instability is severe. But they are also costly, carry significant risks, and often fail to address the biological causes of degeneration. As our understanding of spinal aging deepens, a transformative shift is underway. The move from cutting out damaged tissue to regenerating it, replacing scalpels with senolytics, stem cells, and molecular therapy. The future of back pain therapy may not lie in the operating room, but in a pill. This shift is rooted in a deeper understanding of what actually drives disc degeneration. Once seen as the result of simple wear and tear, we now know that back pain often originates at the cellular level, specifically through chronic inflammation, mitochondrial dysfunction, and the accumulation of senescent cells in spinal tissues. These zombie cells disrupt disc homeostasis by secreting inflammatory cytokines and catabolic enzymes that break down collagen, attract immune cells, and sensitively rewire nerve endings to become hyperresponsive to mechanical stress. Surgery can remove a damaged disc or stabilize the spine, but it cannot reverse these biological cascades or prevent the same processes from affecting adjacent levels. Worse, surgeries like spinal fusion can accelerate degeneration above and below the treated area due to altered load dynamics. This is why pharmacological and cellular therapies are generating so much excitement. Senolytic drugs, for example, have already shown in animal models that they can selectively clear senescent disc cells, reduce local inflammation, and even slow or reverse structural collapse. By eliminating the root drivers of degeneration, these therapies aim to restore the native balance of repair and breakdown within the disc, potentially halting the disease process without surgery. Similarly, stem cell injections, whether autologous or allogenic mesenchymal stem cells, MSCs, have demonstrated early success in replenishing nucleus pulposus cells and boosting extracellular matrix production. Patients in clinical trials have reported reductions in pain and improved disc hydration visible on MRI scans, pointing to a new class of regenerative outcomes once thought impossible. Gene editing may eventually enter this landscape as well, offering the ability to tweak expression of inflammation-related genes, enhance antioxidant defenses, or boost synthesis of key structural proteins like agrecan and type 2 collagen. These biological approaches not only aim to relieve pain but also restore function and prevent further breakdown, shifting the focus from damage control to proactive preservation. Supporters of this shift argue that a pharmacological or cellular approach is not only more targeted, but far less invasive. Imagine a future where patients receive a course of senolytic pills or a single targeted stem cell injection, followed by physical therapy and lifestyle interventions, not weeks in recovery after a spinal fusion. Recovery times are shortened, risks of infection or surgical complications are eliminated, and the patient's own biology becomes part of the solution. This would democratize care, especially in places where access to high-tech surgical interventions is limited or prohibitively expensive. Still, there are good reasons for caution. First, many of these therapies are still in preclinical or early-stage human trials. We do not yet know their long-term efficacy or whether they will work equally well in older patients with advanced degeneration versus younger patients with early-stage disease. There are also concerns about delivery, how to get drugs or cells into the avascular disc space effectively and consistently. And while senolytics promise specificity, off-target effects, especially in the brain or immune system, must be rigorously monitored. The disc's low blood flow also raises the question of how well oral medications can reach their target without direct injection, which reintroduces procedural complexity. Moreover, not all cases of back pain are driven by disc degeneration alone. Facet joint arthritis, spinal stenosis, ligament laxity, and nerve entrapment often coexist with disc disease and may still require mechanical solutions. In these cases, pharmacological approaches may be necessary but not sufficient. Then there's the issue of clinical inertia. Surgical solutions are well established, reimbursed, and deeply embedded in spine care systems around the world. The infrastructure to support regenerative therapy, personalized dosing, biologic storage, advanced imaging, and follow-up will need to evolve before these new treatments can become standard practice. Yet the trajectory is clear. As aging populations grow and the burden of back pain rises, the need for minimally invasive, disease-modifying therapies will become more urgent. Surgery will not disappear, but it may become a last resort rather than a default. Pills instead of plates, regeneration instead of replacement, that is the future many researchers and clinicians are working toward. In summary, the debate over the future of back pain treatment is no longer simply theoretical. With senolytics, stem cells, and gene-based tools advancing rapidly, we are moving toward a model of care that treats spinal degeneration not as a mechanical failure to be fixed, but as a biological imbalance to be corrected. It's a bold shift, one that will require scientific rigor, regulatory innovation, and clinical humility, but one that offers a fundamentally new vision: less cutting, more healing.